Hello, friends, and welcome back to Science with Mr. Co. In this episode, I'd like to introduce you to a simple machine called a lever. A lever is considered a machine because I can put force in on one side of it. See my hand over here? I'm going to press down on one side of the lever, and that force is going to come out on the other side of the lever. By pressing down on one end of it, the other end of it goes up. Now, what's special about a lever is that it can give me something called mechanical advantage. All that means is that when I put a certain amount of force in on one side of the lever, by using mechanical advantage and setting the lever up just right, more force than I put in can come out on the other side. I'll show you what I mean. A lever is made of two parts, okay? This part is called the fulcrum. It's the part that the lever is balancing on right now. The side-to-side part here is called the beam. Now with this lever, I can freely change where the fulcrum is. So that means I could set it up so that the beam is longer on one side of the fulcrum than on the other. I could make it out like this, or I could make it go the other way, more like that. Okay? Now, to give myself a mechanical advantage, what I want to do is make one side of the beam longer than the other. That is, I want more of the beam to be on one side of the fulcrum than on the other side. Okay? If I've done this right, that means I could put something real heavy on the short side of the beam. Big old Einstein book. And now, because of mechanical advantage, because the fulcrum is closer to the end of the beam that has the load on it than it is to the other end. Now when I press down on this end of the lever with a certain amount of force, I get even more force on the other side, and I can lift up Einstein. Oops, he fell off a little bit. Now, things are different if the opposite situation happens. For instance, if I set the lever up so that the part carrying the load is further away from the fulcrum, and the part where I add my own force is closer to the fulcrum, now I don't have mechanical advantage anymore. Now, really, I have a mechanical disadvantage because I could press and press and press and press, and look at the beam bending like that. I'm pressing so hard, guys, and Einstein is barely moving. I'm in a mechanical disadvantage situation. To give myself mechanical advantage, I just have to move the fulcrum closer to Einstein. There we go. And now, look how easy it is to lift his big brain up and down. Mechanical advantage in a nutshell. So, I've managed to convince a little Lego friend here to help us demonstrate mechanical advantage in another way. He is going to set up shop at one end of our lever. Notice that in this setup, our lever looks quite different, doesn't it? Most of the beam of this lever is on the right side of the fulcrum. Only a little bit of the lever is on the left side. In this experiment, I'm going to drop this tennis ball onto this end of the lever, and we're going to try to see how high up this ruler Mr. Lego Man will go. Now in this setup, with so much more of the beam on the right side of the fulcrum, we're at a heavy mechanical disadvantage. That means when I add force to the short end of the lever here, a lot less force is going to be put into the other end of the lever. So when I drop the tennis ball onto this side of the lever, and we measure how high Mr. Lego Man goes against this ruler here, we'll remember that before we make our next adjustment. All right, let's try it. I'm gonna hold the tennis ball about 3 inches, well, more like 5 inches, above the left-hand end of the lever. Meanwhile, we're gonna watch how high that amount of force can make Mr. Lego Man go. Ready? 3, 2, 1, launch. Okay, not bad. That looked like about 4 or 5 inches, I guess. We've got to pause here to reset the catapult and try it again. Okay, we're all reset here. Mr. Lego Man is back in position. Our lever is reset. Except this time, you may notice that I've moved the fulcrum a little bit to the right. A bit more of the beam of our lever is now on the left-hand side of the fulcrum, and a bit less of our lever is on the right-hand side. So now, when I drop the ball from the same height above the ruler onto the ruler, do you think Mr. Lego Man will go higher or less high than he did the first time? We have a little bit less of a mechanical disadvantage now, because a little bit less of the ruler is on the right-hand side of the fulcrum where Lego Man sits, and a little bit more of the ruler is on this side. Major prediction yet? Okay, time to try it out. Our ball sits about 5 inches above the left-hand side of the lever, just like it did before. I'm dropping it from the same height, so the same amount of force is going to go in on the left-hand side of the lever. Let's see how much force comes out on the right-hand side. Ready? 3, 2, 1, launch! Whoa! He went all the way off the screen and landed over there by the telescope. Pretty impressive. He flew further that time than he did the first time, because he has a little bit less mechanical disadvantage. In these side-by-side shots, you can see mechanical advantage in action. First with our little lever catapult device, and then with our Einstein lifting device. I encourage you to try this out yourself. Make yourself a simple lever, and see what it's like to lift some heavy things when you put the fulcrum in different places. Let me know what you think. I'd love to hear from you. Until then, I'll see you next time.